So I'm on a website called GeoGebra. We've got a great little app here. So what we would have been doing with this in the past is maybe finding the area under that curve. If we're doing Riemann sums, we could do a right-hand endpoint with 9 rectangles from 0 to 9. Here's my function. Okay, I'm not sure what this does. Oh, that changes the bounds. Okay, so we'll stay at 0 and 9. And then, so it's a little different. What we're looking for is a volume of the solid. So it's hard to visualize. This is one of the better things I've found to help visualize. So here's kind of a 3D graph. And I'm going to kind of go almost head on here so you can kind of still see those rectangles. And I think this is the one I want. Yeah, so if you take those rectangles and you spin them around the x-axis, okay, that's what we're doing, a revolving of those rectangles. And the result are these discs, okay? And each of those discs is a thin cylinder, all right? And the radius of that cylinder matches up with, it's wrong button again, the radius is the height of each of the rectangles. So as the function changes, the height of that rectangle changes, therefore the radius of the disk changes. Now we could change the function, we could change the number, the upper and lower bounds, we could even change the number of rectangles. So as I increase the number of rectangles, you can see the accuracy of the volume would be much closer to that of the curve, and we would get a more accurate volume. So what we're going to do is we're going to integrate, instead of doing the area of a rectangle, we're going to do the volume of a cylinder, which would be pi r squared times h. But since we're using, in this case, 50 down here, 50 different disks, we're really trying to get that to be infinite. So therefore, the height of those disks is infinitely small, but there's infinitely many of them. Therefore, we can use the fundamental theorem.